right? So the init method, if you remember, is called the minute you create an object, the underscore underscore init underscore underscore method is called by the object. Let's also define the underscore underscore call underscore underscore. This also takes self. Let's say we have star arguments and then we have some keyword arguments too. Let's say keyword arguments. Cool. Take both of them together. And all you have to do in the call is print all the arguments. Print arguments are arguments, comma, keyword arguments. Cool. Okay. Now let's define an object x which is going to be equal to, let's create, of course, an object of class A. We created with the class name. And then, of course, we print. Let's print now saying that, we are now going to call the instance. Now we, instead of, we say x, we can have something like this, 3, 4, x equal to 11, y equal to 10. Now let's print. Let's call it again. X of 3, 4, x equal to 11, y equal to 10. Okay, so we can do a function f5, run this out. Let's say decorating classes. So you have an instance of A that was initialized. We are now going to call the instance. So what are the arguments? The arguments are, so the minute you call the instance, you get the underscore underscore method of call is just called. The minute you say x of, just pass some parameters, the minute that call method is called, underscore underscore call underscore underscore. You can do that anytime you want. All right. Okay. So now we can write a class for the Fibonacci function by using underscore underscore call. So how do you do that? Okay. Let's say we'll define something called as a cache. Okay, a cache which is going to be a dictionary, and that is going to be one of the one of the attributes of an object which creates it. Okay, let's create a class Fibonacci. So let's say a new file, and we're going to say class Fibonacci, and then we say def underscore underscore init underscore underscore, and then you have self. Okay, in the self, let's say self dot cache. Self dot cache over here, it's going to be an empty cache. Okay, and then we do, so that's where we define a cache, which is a dictionary for self, which means for the object that is calling it. It is going to define a cache. Okay, and then we do a def underscore underscore call underscore underscore, and then you have a self comma n, right? If n not in self dot cache, if n not in self dot cache, if n is equal to 0, self dot cache. So we are going to do a call. Okay, wherever it calls, it will call it with n, the value n, right? So if n is equal to 0, we'll say self dot cache of 0 is equal to 0. We'll just make the self dot cache of 0 as 0. elif, let's have an elif out here. N is equal to 1. Fibonacci of 1 will nothing be 1 itself. Self dot cache. Let's have for 1, Fibonacci of 1 is going to be 1. Else we could say self dot cache is of n is going to be equal to, keep calling self dot underscore underscore call underscore underscore, call it with n minus 1 and call it with, of course, plus self dot underscore call underscore, and then you say n minus 2. If you remember Fibonacci of 0, that means the 0th element in Fibonacci is 0, the first element in Fibonacci is 1, then you have 0 plus 1, that is 1, then you have 1 plus 1, that is 2, and so on. Right? Finally, you just need to return self.cache. Just need to return n. That's it. Correct? Now, once you do that, okay, the return should be done here inside this if or outside this if. I think it's going to be, yeah, it's going to be here, not there. Okay, once that is done, let's go on to defining an object. Fib is equal to Fibonacci. Okay, for I in range 15, let's print the Fibonacci of I, and let's say end is equal to, let's define the end with a comma so that they're printed one after the other. Save, let's say Fibo, right, 0, 1, 1, 2, 3, 5, 8, 13, 21, 31, and so on. So as you can see, your values which are there, you are actually calling the call. Whenever you say fib of I, whenever you call the object and you pass the parameter, you're doing the call. So when you say fib of I, for instance, for the first one, fib of 0, it called with passing 0. If 0 not in self.cache, if it is not there, then it should go in. Okay, so if it is not there, it goes inside. It's not there for the first time. So if n is equal to 0, self.cache 0 is equal to 0. I just need to make a cache out there, cache memory, and then I have a self.cache of 0 as 0, and then if dot, yes, return out there. So you return that self.cache of n, self.cache of 0 is going to be that. So this is how you create already a cache and keep it so as to spare the time and also the effort. Okay, with this we have understood how to do the call function. Okay, now how do I use this particular class? How do I use all this particular information that I have done using how do I use a class as a decorator? Okay, so a new file and then use the class as a decorator. Let's say def decorator 1. In this I pass f def helper. I just print decorating what? F dot underscore name underscore, and then call the function f. If you remember, this is how the decorator is. Return helper. Sorry, it's going to be, yeah. Now, of course, foo, define a function foo which needs to be decorated. Say at decorator 1. Okay, and call the function foo and say, let's say decor class. Yeah, that's it. So you have the decorator being started out there, decorating foo, high from foo. So this is how you did a decorator. But now how do you do this same task using a class? How do I do the same task using a class? Instead of having this function, now I'm going to have a class. Let me call this as decorator2. In this particular thing, I'm going to have a def underscore init. The function is passed out here. Self.f is equal to f. Now all I need to do is def underscore call underscore self print decorating self dot f dot underscore name underscore. This is going to be how you get your, so now your function is added as one of the attributes of the object. That's what you're adding it as. Is that clear? Now you could say, you could just call self.f and that function will be called. Now you don't need decorator 1, you're just going to decorate the function with decorator 2, right? That's it. Now whenever you call, so add decorator 2, that means whenever this function is called, it will call the underscore call method, right? That's it. And then let's say save function f5. Is that clear? So this is how you have decorators in classes. Hope this is quite understandable and quite informative, right? With this, we finished a very important concept of decorators. We can now go on to more complex things in the coming lectures. Okay.